Welcome to a new episode and video on my Arduino Yun, which is an Arduino with embedded Linux, which enables to store data and have a connection to the internet. And yes, that makes it an IoT, Internet of Things device. And in the beginning I had a struggle with it because it has wired but also a wireless connection, and the struggle was that they were kind of mixed. The only thing that I could do was via a graphical interface, which is still there, trying to get both of them working the own way. So using one and the other in separate ways, and that turned out to be a complete nightmare, because when I assigned one setting to this one, the other one, the wireless, got the same thing. And when I assigned a static IP to this one, the other one got it as well. In the end, I managed to get one disabled, which is the wireless one. So I only have now this one enabled, which also led me to do one other thing: disable the whole IoT capacity possibility. So right now it's no longer IoT. It's just now another Arduino with, be it some limited possibilities, not as much as, for instance, the Mega 2560, Mega 80K or any other one. But it has Linux, so I can access it from it, and using an SSH terminal I can do a lot. I can also access the internet, no problem. But the Linux version on it, which is called Linino OpenWRT Wireless, it's embedded Linux, it cannot be properly updated. So I would have to upgrade, and I'm waiting with that. Anyway, apart from that, oh, by the way, there's a new version which I don't know. I never played with that. I only played with this one, and this one is no longer available. But it's connected to electronics and some physical mechatronics. And lately I have been struggling with Octave for getting a nice graph out of data acquired from the electronic settings of the spot meters, the lights, and the signals from and to the mechatronics, stored on this USB stick, copied from USB stick over the network to computer with that Octave, and I've been programming into Octave to get the graph, and that is not yet functioning. But I want to focus on one other thing right now, this, because this device covers shortly, for a short time, a light from a phototransistor. Now the point is that this is a voltage divider, and when I look at the signal, then that signal is not detected. So why am I using a voltage divider? Out of safety, because with another project not using a voltage divider I ruined a port. But Arduino is something different, and I should skip this one. So the signal is going over this little brown line, and I should actually put this one right there. Where it enters the circuit, there it should be. And then see if I get the signal anyway. So I have some rewiring to do. Then also here is something going on because there's no light here. And another thing, the previous episodes I struggled with this one, with this button. Well, a button on this location. And that is, by the way, this one. And yes, I replaced it. What is the difference? Apart from being the same kind of button, look at the car. This one has a black button. That one is blue. What's the difference? I don't know. The physical difference I don't know. One thing I do know is that this one doesn't pop out yet. Nope, it doesn't pop out. The other one would pop out immediately. So that's one difference. Now time to put a wire from here to here, and I'll probably use another wire for it, not remove this one. Although it makes no sense to do that in that way. But anyway, the strongest signal will win, and it's not to this wire, it's to this one, the first one, because of the lane that it is connected to, and that is this one, not that one. Anyway, let's go there. Alright, so different camera, as you may understand. This is for screencast. Data not input. I have set the date once again, right here. No input. Oscilloscope. Okay, that one should be right like this. And here is a wire to be rerouted. So let's see if I can take a shorter wire or something like that towards this end, if anyway possible. And I have a problem with that because the preformed wires are too long or too short. So I will have to improvise once again, and I have a wire here, but that is really too short. So yeah, going on the spot once again. I shouldn't do it, but doing it anyway. So for now, using this very long wire, and that one is going right here, and then this end I will do right let me twist the end of the wire, always nice together, and that one goes here. So now with this rerouting, the signal from this goes straight to this first green wire, straight there. Now it's the question, where does it go to? And that is this black wire, which goes to a 4. So if I now give some input, it would be nice to know if a 4 gives some input. Oh wait, I can do that better, because analog in pin A4. And there I've made a mistake, which I corrected for another project. I should not use analog for it. A phototransistor is a digital switch, so it should be not analog, it should be digital. So now the question is, which one of the ports is still free? And that is a very good question. So I have to look right here, that is here somewhere, to find a port that can read, that is free and can read digitally, and which has also pulse modulation, and that is not every port. So looking at all these ports, they are all occupied. So that gives me a problem. How to deal with that? Because the voltage makes no sense. I can just pull this wire out, because it's analog and not 1-0 output from the transistor. And this wire is there not for nothing, because I already doubted this is going to 2 separate ports. I can of course test if either one of those wires can come out, and then I would have one of those wires available. Let's see which one is the first one. Oh wait, I have available, because they don't need to be pulse modulated output, it has to be input. So that means that I have port 2 available. That's a good one. Now if only this wire is long enough or robust enough, and I doubt that, so I need to replace the wire. So yeah, replacing, and of course changing the schematics. Alright, and now I have put a wire from here to port 2, and that has to be changed then in the schematics. So where I have, yeah, now it's got a bit like this. So this was the input from the phototransistor. That is going to be different, because I will be adding constant integer digital in 2 from port 2, digital input, well, it's just input, of course digital, input from phototransistor, because it's digital. Which also implies that I have to change the rest of the algorithm. And it used to be a 4, A4, find. There we are, 06. So instead of this one, I am getting digital read, digital in pin 2. Is that correct? No, it's not correct, because I just made it digital in. Okay, let's keep it digital in, I don't mind. Going back to A4, which is right. Oh, there also. Oh, that's a good one. So 06 is not in pin, but it is in 2. And this whole thing is going oh, that's an obvious one. So this will be here. No. And do I have it somewhere else? Yeah, I do. So this means that I have to change everything. And analog read doesn't do a thing anymore now. Is there any other place? Yeah, there is. So changing one thing leaves quite a bit of consequences for the rest. And also with this one. So and another one. So change one thing and you have to change the whole thing throughout the algorithm. Not a problem, but takes time. And then we're back, so we're done now. Also, I have to upload it, and I have to change this one, because this is, now I have to select, copy, paste, and no, well, A4 is going to be no longer there, but and that's a bit of problem. Okay, like that. C, and this is of course being 2 now. Digital 2, A4 no longer used. That's one thing. Now upload, read and see, because now also for here it's better if I put this one right here, and on the oscilloscope it's this one. So now the question is, do I actually read a signal? Because right now I sure don't. So I might have a problem with input. Anyway, we'll see. First thing, upload. This is all set correctly. Yes. Go. Where? Oh, right. This is better. Go. Now it's good. Initial upload password. And that's what we have to see. Now there is a slight problem, because here is the installation with a lamp, and above the lamp is a transistor. And taking a look at the lamp, it is a faint glow, which reminds me that the 5-volt voltage from here is not enough to have a nice signal, which is also very clear if you look at this one. This is the signal coming from the transistor. It's 0. Now if I take this flashlight, and if you see my previous videos you may recognize it, and I shine like this, it may, it probably won't help, because I'm not straight right under the transistor. So the problem is now that the voltage is too weak to have the lamp shine fully. I can of course put it to the power controller from fischertechnik, which gives 9 volts, but that's not my idea of this circuit. So this, despite the fact that I now have changed the circuit here and the wiring there, it won't help. It will only help when I see something change here. So how to deal with that? Looking for a voltage increase can be done, but not quite sure if I have the right equipment, so I'll have to let that go for now, unfortunately. That is not going to work out. Then I can try to once again work with this motor, and last time that was a problem as well, because it didn't want to run even with everything there. So giving it some nice stuff, it's not working, and let me check if all wiring is still connected. As far as I can see, yes it is. So in comes a screwdriver again, and okay, this works. And then okay, right. Now you see here, and that is this probe, that it is predominantly low, so that is why that LED is off. So let me see to change a bit. It doesn't change, so that is too bad, but it should be lit up, and that means that this one will also not work. Nope, correct. This one will work, yeah, just a very short flash. Last time this one did work, so let's see for this one. Yeah, working. This one. This one is not working. Yeah, now it is. So, and the feed has ended. And let's check this one. No, not. Yep, just did, and there will be and in this file there will be a lot of zeros by now. Also a lot of good stuff. But now I also see that here's 1000 and here's 1002. Here as well, but then this will be just an ordinary value. Alright, where to go next? Good question. Basic conclusion is that things are not going the way I intended to do, but let's also focus a bit here, and I still have some Octave to take care of. And timing again. So let's see how much time we still have left. That's not much. I think time is going out. Okay, I will go slightly over time, but it has to be. I copied the present log file to the computer, so now I can go to Octave, run the program, and then see whatever happens. Will be much, I'm afraid, but anything is better than nothing, so let's run. Yeah, that is nothing indeed. Why? Well, let's take this one out. I should. Alright, that's the point. Comment. Now run again. I said run again. No, and taking these out, run again, and now I have some line, but this is only for one particular value. How about, and I recall that I did this last time as well, and do I get two? Yeah, two now, a green and a blue one, and they are from 1000 and 1001. Now how about red one, and then 106, because I still have to find that one out. How do I get all these different values in it? See, and there it goes wrong for some reason, although I have everything in it. So but again, that may be because of time. So let's see, this is 1400, this is 400. What do I get if I do it like this? 620. So this may indicate that if I zoom in, that I have a different graph, or zoom out, I will have a different graph. Let's do that one. So and this is minus. This is not what I expected. Okay. This is not what I expected. So what happens when I include these ones? Run. Do I see yellow somewhere? I don't see yellow. What I can do, and I will try to do next time, is have subplots. See if I can find any difference when I put each one in a subplot. But that's for next time, because this is not working out clearly. So 2 can be done, and this works kind of. Alright, I will have to leave it at that. That means that I'm at the end of this video now. Two rewirings, two things working but not electrically. So this flashlight has to come up again, but as yet the construction is such that it doesn't work. Thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up and leave a comment or suggestion. You can also follow me on Twitter and Instagram. And please support the blog and videos by making a small donation via Wire or PayPal. You can also become a patron and have your name mentioned. This is going to be continued. So once again, thanks for watching and bye bye.